Now this question will be given 5 masses M1, M2, M3, M4 and M5 revolve in the same plane. Okay, so now we are talking about several masses revolving in the same plane. Magnitude of M1, M2 and M3 are 5, 2.5 and 4 kg respectively. Their angular positions are of M2, M3, M4 and M5 are 60, 135, 210 and 270 degrees from M1. So that means M1 is the reference point for all the angles. So we are just asked to determine the masses of M4 and M5. We've been given M1, M2, M3. So all we need now is that of M4 and M5. Okay. So now the first step is to draw the table. So the table, the first column we have the masses. So the first mass is 5, the second mass is 2.5, the third is 4. M4 and M5 we do not know. So now from this question we are not given the radius of the crank. Okay, so now before we talk about radius, now let's move on to the space diagram. This is the space diagram. We have been told that M1 is the reference point. Since M1 is the reference point, it's going to be horizontal in this way. So the next mass is M2, and we are told M2 is at an angle of 60 degrees from M1. So you can see this is our M2 at an angle of 60 degrees. The next one is M3, and M3 is at an angle of 135 degrees from M1. So that is it. The next one is M4. M4 is at an angle of what? 210 degrees. So you can see 210 degrees at an angle of 210 degrees from M1. While M5 is at an angle of 270 degrees. Okay, so now we're not given R from the question. We're not given the radius of crank from the question. So we need to make an assumption. We need to make a meaningful assumption that our R is constant across. You know, if we pick a value of 1 throughout, so that means we multiply M multiplied by R, we have 5. So if we also take a value of 2 constant all through, it means our first polygon will all have a value which is times 2. You know, okay, how about when we pick a value of R as our radius? So now R throughout as our radius. So it means here where we have our first column, we are going to have, instead of we having FC over omega square equals MR. Okay, so now we are now going to have FC over omega square R equals M. This means the unit here we are going to have is going to be kilogram. Okay, so that means we are left with 5, 2.5, 4, M4 and then M5. Okay, so now from this column, what are the unknowns? The unknowns are M4 and M5. Since we only have 2 unknowns in the couple polygon, that simply means we can use our, we only have 2 unknowns in the first column. That means we can use first polygon to solve this. It means that just considering static balance, we are going to solve this. So now I'm considering a static balance. Now we're going to use the scale for this column. So the highest value here is 5. You can just say 5 equals 10 centimeter. So if 5 equals 10 centimeter, so that means 1 centimeter equals 0.5 kilogram. Okay, so that means 5 centimeter equals 0.5 kilogram. So the next value, which is 2.5 kilogram, 2.5 kilogram will become 5 centimeter. Okay, or since 5 centimeter equals 0.5 kilogram, so that means 1 centimeter automatically becomes 0.5 kilogram. Okay, so the next mass after 5 kilogram, that means your 5 kilogram will become 10 centimeter, and then the next one, which is 2.5 will become 5 centimeter, followed by 4 kilogram, and 4 kilogram, that's going to be 8 centimeter. Okay, so we don't know that of M4, we also don't know that of M5. So with this, we can construct a false polygon. So we already told that the horizontal is M1, and this is our M1, and then M1, which is 5 kilogram, has 10 centimeter. So it means from here to here is 10 centimeter. So the next one, looking at the space diagram, is M2, and M2 is at what angle? M2 is at an angle of 60 degrees. So that means from this point, we take our protractor and measure 60 degrees. Okay, so this is 10, 20, 30, 40, 50, 60. Okay, and then you join. So, but what's the magnitude of M2? Okay, M2 has a magnitude of 2.5, which is the same thing as 5 centimeter. So you take a ruler and then measure 5 centimeter. Okay, so this is your arrow. This is your arrow here. You can call this point A, call this point B, and this angle of 60 degrees. So now you're expected to draw a horizontal line here, and then another vertical line here. So you'll be able to place your protractor in order to measure the next angle. So in order to draw the horizontal line, you can take your set square, ensure it is straight with this, and then bring it down here, and then you draw your horizontal line. Okay, so now you can also draw your vertical line by ensuring this is straight. So once this is straight, you draw your vertical line using two continuous lines. So now you can measure the next angle, and the next angle after 60 degrees is 135 degrees. So now you place your protractor, so you can see that your 180 is straight here, your 0 is also straight here, and then your 90 is also straight here. So 0 is straight here, 90 is straight here, 180 is straight here, and then you measure 135. So from here to here is 90, 100, 110, 120, 130. So 135 will be somewhere here. Okay, then pick up your ruler and then you join. So what's the magnitude? The magnitude this time around is 4 kg, and that 4 kg is 8 centimeter. So you measure 8 centimeter. Okay, so now you can write 8 centimeter here. Here you write 5 centimeter. Here you write 10 centimeter. So indicate your arrow. Okay, so now the next one is M4. So we know the direction of M4. We know the direction of M4, and the direction of M4 is, that's after 135, the direction of M4 is 210. It means we need to draw another horizontal line and vertical line here, so we'll be able to place our protractor to measure 210 degrees. So just as we did here, so pick up your ruler and your set square, and then set it here. So once you set this one and you see that it is set, once this is set, you can now draw your vertical line here. So this is your vertical line, and then you can also draw your horizontal line through this point as well. Okay, then you pick up your ruler and make it longer, and then you can now take your protractor and then measure angle what? 210 degrees. Okay, so all through here we have 180. So 180 from 210, 30. So it means it will have to go down. So it means we have to come this way. It means we have That means we have 10, 20, 30 here. So that's 30 plus 180, 210, and then we join. So now this is our M4. So M4 is 210 degrees. Okay, so we can indicate this angle as well. This is 135 degree. This is 60 degree. So we do not know the magnitude of M4. That's what we are looking for, but we know the direction. Okay, so the next one is M5, and we're told that M5 has an angle of 270 degree. Of course, 270 degree, we have this as our origin. This is 90, this is 180, this is 270. It means 270 is going to be from here like this. Okay, so automatically know that 270 degree is going to be vertically downward this way. So since we do not know the magnitude of this, and then we know that this is supposed to form a closed false polygon, since the masses are rotating in the same plane, that implies that it is statically going to be balanced. Okay, so that means since we are going to have a closed false polygon, that means where the beginning of this point, that's going to be the ending point of your fifth mass, which is M5. Okay, so automatically you know that the last mass is going to close at this point, and since it's going to get close at this point, we know that here we are going to have 90 degrees. Okay, this place is going to be 90 degrees. So anywhere from here, we can project a vertical line here, a line that is perpendicular to this. So the line perpendicular to this is going to be this. Okay, so automatically this is going to be our M5. This is our M4. So this is the direction, and this is the direction. So when we measure this place and then multiply by the scale, we are going to have the magnitude of M5. When we measure this place and multiply by scale, we're also going to get the magnitude of M4. So this is C, and then this is D, and then back to O. So now on measuring CD, okay, on measuring CD we have CD. So measuring CD, we're able to get CD as 8 centimeters. So that means CD is 8 centimeters. Okay, how about OD? OD should be around 6 centimeters. So we also got our OD as 6 centimeters. Okay, okay, that should be around, okay, that's around 6.2 centimeters. Okay, so now for us to get M4 is going to be what? CD multiplied by scale, and CD is 8. So what's the scale? The scale is 0.5. Okay, recollect we said 1 centimeter equals 0.5 kg. So 8 times 0.5, and that's 4 kg. It means the magnitude of M4 is 4 kg. How about M5? M5 is what? OD multiplied by scale. And what is the distance OD? 6.2. So that's going to be 6.2 multiplied by 0.5. Okay, and then the final answer is what? 3.75 kg. Okay, so that means the magnitude of M5 is what? 3.75 kg, approximately 4 kg. Okay, so and those are the solutions, M4 and M5, as required for us to calculate.